All right, last video on this problem, problem 61 on the math subject GRE practice test. The solution to this problem implies that the cosine of pi over 5 plus the cosine of 3 pi over 5 is just equal to a half. Now I thought that was kind of interesting and would probably be fun to prove. I just finished proving it algebraically, but it turns out there's a proof that you can do purely geometrically, which is kind of fun. So that's what I'm going to do in this video. The trick to the geometric proof is to consider this regular pentagon. This picture is kind of overused, so maybe I can redraw things down here and really focus on the part that I care about. Sure, that'll work. I've got this point up here and I'm calling it Z. It corresponds with this point. What I know is that this angle right here is 36 degrees, or pi over 5. And what I want to figure out is the x coordinate of this point. To do so, all I'm going to do is draw a bunch of triangles. First, we'll create a right triangle. Then I'll create another right triangle by connecting this point to Z to the point 1, 0. So first note that this triangle right here is isosceles. Right, this length is 1 and this length is 1, thanks to the fact that it's inscribed inside a unit circle. So therefore, this angle up here and this angle down here are congruent. Because I used up 36 of my 180 degrees in this triangle right here, I have 144 degrees left here and here. So each of these measures are half of 144 degrees, in other words, 72 degrees. What I want to do is draw another triangle by connecting this point Z to some point down here so that this triangle is isosceles. In other words, this measure is 72 degrees. Well, look what happens. If this is 72 degrees and this is 72 degrees, I've used up 144 of my degrees of this triangle, so I have exactly 36 left for up here. But a minute ago, we decided that this angle in green was 72 degrees. So if this angle in purple is 36 degrees and this angle in green is 72 degrees, then this angle here in red must also be 36 degrees. Right? 36 plus 36 gives me the 72. But wait a minute, if this is 36 and this is 36, then this triangle is isosceles, so this side length is the same as this side length. Whoa, you're throwing a lot of math at me. What point are you trying to make? The point that I'm trying to make is this side length here, maybe I call its length A, is the same length as this side length here, because this triangle is isosceles, and it's also the same length as this side length here. Also, because this is a radius of the unit circle, if this is A, this length from here to here is 1 minus A. With that information, I can figure out the coordinates of Z. The trick to doing so is recognizing similar triangles, so I'm going to redraw these triangles. The first triangle I want to focus on is this big one here, which I'll copy here. Note that the length of the base here is A plus 1 minus A, in other words 1. Either because the triangle is isosceles or because this is the radius of a unit circle is also 1. And this length I'm calling it A. The other triangle I want to draw is this one here. These angle measures are both 72. Therefore, this angle measure is 36, and I know that these side lengths are both A, and the length of this base here is 1 minus A. Because the measures of each of these triangles are 72, 72, 36, these triangles are similar, so this 1 divided by this A must be equal to this A divided by this 1 minus A. To solve this equation, multiply both sides by 1 minus A, multiply both sides by A, I get A squared equals 1 minus A. In other words, A squared plus A minus 1 equals 0. I'm a little bit low on room, but I'm pretty close to the end. Maybe I can squeeze this over here. To solve this equation, either use the quadratic formula or complete the square. I'm going to complete the square. I got A plus 1/2 squared. That gives me the A squared and the A. It also gives me a 1/4. I don't want that 1/4, so I need to subtract a fourth. That negative 1/4 and this negative 1 gives me negative 5/4. This equation's easy to solve. Just add 5/4 to both sides. Then take the square root, then subtract 1/2. I get A is equal to negative 1/2 plus or minus the square root of 5/4. Since A is a positive side length, I'm not interested in the negative solution, so I get that A is equal to maybe negative 1 plus root 5 over 2. So then I can figure out 1 minus A, just be 1 minus this thing, or 2 over 2 minus this thing. 2 minus negative 1 gives me 3, minus the square root of 5, divided by 2. I have values for A and 1 minus A. Now it's easy enough to figure out the x coordinate of this point Z, which would correspond with the cosine of 36 degrees. In other words, the cosine of pi over 5. It's just going to be equal to A, this length here, plus half of 1 minus A. So negative 1 plus root 5 over 2, plus half of this number. So plus 3 minus root 5 over 4. To sum these fractions, think about this as negative 2 plus 2 root 5 over 4. Negative 2 plus 3 gives me 1. 2 root 5 plus negative root 5 gives me root 5, and my common denominator is 4. The cosine of pi over 5 is 1 plus root 5 over 4, the same value that we came up with over here when we solved this thing algebraically. You could draw a similar picture to figure out the cosine of 3 pi over 5. To do that, you need to know the x-coordinate of this point. Maybe you can draw a picture pretty similar to what we did down here. I'm all out of room and don't know that that's different enough, so I'm going to call this good.